Geotechnical engineering is a civil engineering discipline that focuses on using rocks and soils for engineering purposes. Most infrastructure projects start from the ground up, so geotechnical engineers need to participate in a wide range of interesting projects, including the design of foundations in skyscrapers, tunnels, land reclamation, mitigation of earthquake and landslide hazards, exploring for natural resources, and dealing with ground contamination. The main challenge in geotechnical engineering is that soil and rock are natural materials, which means that they are highly variable. A structural engineer can order steel members to meet his or her design specifications, while geotechnical engineers have to make best use of the existing geomaterials in the ground no matter how weak and variable they are. The most challenging aspect of geotechnical engineering is that most of the time we never end up getting a complete picture of what is in the ground. We have to leverage our fundamental knowledge and experience to reduce risks while delivering a safe project on time and within budget. Soils are perhaps one of the most fascinating and complex construction materials. To give an example, have you ever wondered why you're unable to build a sandcastle using only dry sand? But when you add a bit of water to the sand, it can stand up almost vertically. Or when the tide comes in, your sandcastle collapses. The reason is because water between grains of sand govern the strength of soil. Depending on the amount of water in the pores, water can act to destabilize grains by pushing grains apart, or strengthen grains by pulling grains together using surface tension. We see these basic principles related to building sandcastles applied to everyday geotechnical projects.
Transportation engineering can be under civil engineering. According to Norman Dictionary, the word civil means relating to the only people or things in a country that are not part of military, government or religious organizations. Transportation is about the basic need of people. For example, Hong Kong people need to go to work or school on weekdays, and they always travel by public transport. Transportation is related to the daily life of people. Therefore, transportation engineering was traditionally under civil engineering. Transportation is about the movement of people. The movement of people can be by different means of transportation. For example, sea, land, and air transportation. Transportation is more than what you can commonly see on roads. For example, public transport, taxis, bicycle, private cars, or other transportation modes. Transportation can also be about vertical or horizontal movement of people, say by lift or moving walkways. Besides the movement of people, transportation is also about the movement of goods. You can order products online. Someone helps you to deliver your product to your home. That involves the movement of your product from a warehouse to your home. If the product is produced outside Hong Kong, the delivery often involves more than one transport mode, so as to minimize the transportation cost. Transportation engineering involves the use of scientific principles to improve transport system and mitigate the impacts of traffic. The impacts of traffic can be congestion, vehicle emissions, and traffic noise. More vehicles on roads often induce more serious congestion, causing more delays of travelers, and can make the environment noisier, affecting the people in the noise-sensitive receivers such as hotels, schools, and hospitals. Transportation engineering involves planning, design, control, and management of transport system. The aim is normally to improve the system. One example is traffic signal control, to design the green time for vehicles and pedestrians at an intersection to minimize their delay. Another example is bicycle repositioning in a bike-sharing system. Very often, some bike stations or areas have an oversupply of bikes, whereas some other stations or areas are undersupplied. It is required to use the trucks to take bikes from surface area or stations to the deficit area or station to meet the bike demand with supply. It involves the design of truck routes and determination of the quantities of bikes to be picked up and dropped off at each visited station or in each visited area.